Yes guys, welcome back to Pure Math School. And last in our previous video we looked at some of the basic identities that we really need under basic algebraic manipulations. Those are the three quadratic identities, and basically we applied we saw some examples under it that helped us to do some algebraic expansions. And today we are going to basically look at factorization, which we are going to see different ways we can do factorization. That's by regrouping terms using the identities we looked at last time, or by splitting the middle term, which I also gave some hint in our previous video. And so today, since we are dealing with factorization, we need to first understand what a factor is. A factor of a number is okay, let me say factors of a number are actually numbers that if you multiply, they multiply themselves in pairs to give a number. Let's take an example, like let me say 10. For you to get the factors of 10, that means you're looking for numbers that when you multiply you get 10. When you multiply them you get 10. Actually they should be multiplied in pairs, and those numbers actually can divide 10 and leave no remainder. And now we are going to have a look. It's always good to start from 1. That's as you increase, so that would help us not to skip any factor. If we are looking at factors of 10, we're looking at those numbers that if you multiply give us 10. And we can have our first one to be 1. That means 1, which number do we multiply by? Do we multiply to give us 10? We multiply by 10 to give us 10. Another number we can look at, that means we multiply 1 by 10 to give us the 10. Another number we can look at is 2. If we multiply 2, which number do we multiply by 2? Give us 10. We see that the number is 5. And we will see that now our factors will be 1, 2, 5, and that 10. The factors of 10. So you can even list them that the factors of 10 can be given as this: 1, 2, 5, and 10. Whereby 1 is multiplying 10 to give us 10, and 2 is multiplying 5 to give us 10. We look at another one. Let me say when you have 5xy, this x and y are parameters which are unknown, so we just take them as that, and we want to see numbers. That means actually 5xy that can also be expressed as 5 times x times y, of which we know that all these x and y are already fixed, so you don't have anything to look for. And you always remember that 1 is a factor of every number. That means we can also multiply by 1, which does not change that. So that means we actually have the factors are given by 1, 1 multiplying 5 to give us 5. Then we also have x there. We also have y. So we can combine 1 and 5 to give us 1, 5, and xy to give us all that. If we multiply them, we can go back to 5xy. So each one of this is a factor of 5xy. And another one we can see, maybe if we have single term multiplier multiplying a bracket of x plus 2, this can also be expressed as 3x 3 multiplying x multiplying x plus 2. 3 is a factor of 3x into x plus 2. X is a factor of 3x into x plus 2, and as well x plus 2 taken as a whole, like that. So that means our factors can actually here be, since 1 is a factor of every number, we have 1 first, we have 3, we have x, and we have x plus 2. That means you can group this, and you can say 3x and that to give us that. And now another thing we need to know about to help us factorize are common factors. Common factors are actually those factors that appear in both let me say both expressions. Let me say we have an expression of 5xy adding to another expression of I mean a term 5xy adding to another term 10x. Here we have two terms adding together, so that we can, that means this one has factors and that one has factors. So if you see the factors of this we looked at there, we have 1 5x y, these ones, because they multiply themselves to give that. Then this one has factors of 1 10 and x, but 10 is further split into 2 and 5. So for that place we are going to take that. So we have 1 2 5 and x this side, right here we have 1 5 x and y. So for this case we are going to see the common factors. If you see that we have here 5, here also 5, we have 1, here also 1, we have here x, there also x. So our common factors, in this case is given by 1 5 and x. So if you want to know the common term there, now just multiply those 1 times 5 times x to give us 5x. And that's very important when we are factorizing out. That means that common one, you can, if you go back to our 5x y plus 10x, can also be expressed as this. We have 5x as common, so that's a common term, which is our common factor. The common factor in that expression is that. Then you put the bracket. If you remove 5x from this 5xy, we only remain with y. So y remains in the bracket plus. If you remove 5x from this 10, what do we remain with? We remain with 2x. That's all. That's all, because we are seeing from here. We have here 5. We have 5 and x being removed. 5 and x are removed. This and that are removed. So we remain with 2 times 1 only. That's why we remain with 2, because x is already taken. This is what I mean. 1 2 5 x. So 5 and x are off, so remain with 2 and 5. That's why the 2 remains inside. 2 and 1, and 2 times 1 remains 2. Now since we have understood what a how to find a factor and also see what a common factor is, that means we can now start handling some numbers on we can start factorizing some expressions. And the first method we are going to see of factorizing is factorization by grouping. That is regrouping of terms. Now for regrouping of terms, we will simply see what the common terms, or by use of the help of the common factors that we just looked at, to help us group and factorize out expressions. Let us say, for example, 2xy plus 3x plus 2y plus 3, which you're told to factorize. To factorize this, we need to determine our common factors. Here we have x, y, here we have x, here we have y, we have 3. If you see, we can just group this into, let me say this and that. Let's consider those two, this part and that part. So here, if you see this first one, we have our common factor being x, and that means x is here and x is also here, so we can pull out x and remain with what will be inside. We remain with the x is removed from there, we remain with 2y plus x removed from there, we remain with 3, plus here we have 2y plus 3. Remember, this bracket, there's a silent one multiplying that. We have it also as that. Since we have no common factor there, we just leave it as the way it is. But remember, there's one multiplying that, so we pull out the common term. Still common, we have 2y plus 3. Then we have our bracket. If you remove 2y plus 3 from this first term. That means we are going to remain with x inside here. Then plus, if we remove this, we are going to remain with this 1. That means we have already factorized it, and actually these ones are the factors of that expression. And we can check on another example. Let me say 2cd squared minus 5cd squared plus 6d squared c, then plus 4c squared d. We need to look at like terms, those terms that look alike. If you see, if you examine this expression, we have cd squared, d squared c, then this also c squared d. So if you realize, we have cd everywhere, and so that means we can even first group and see, since we have here our term, we have a cd common everywhere, you can first pull it out to see what will come out with inside. If you remove cd out, we are going to remain here with 2d for that case, because you multiply back, you go back there, minus. If you remove out cd, we are going to remain with 5d, then plus. If we remove out cd, we are still going to remain with 6d, this d squared. Then here, if we remove out the cd, we are going to remain with plus 4c only, since d is not squared in that term. So we can see still like terms here. We can just add, these are only d's, we can add them together. We have 2d minus 5d, that means negative 3d, plus 6d, we remain with positive 3d. So we have here 3d plus c, 4c I mean. Yeah, we have 3d plus 4c. And now I think there we can now just open we have now a single term multiplying. Okay, we have a binomial product multiply, which is, we can consider that to be a whole single term multiplying an expression that that has two terms inside. That's simply how we can factorize that. In case you want to open, you can open, and you'll have, in case you want to expand this again, you'll have 3c d squared plus 4c squared d. That's when you expand it back so this expression in its simplest form is actually this, and its factors are cd and that. That's a simple way you can say that. And another another method we're going to see of factorizing is using identities. The identities we looked at last time in our previous video were here. We have a plus b squared, we have a minus b squared, and a plus b into a minus b. This one was given by a squared plus 2ab plus b squared, in which we looked how we can come to this a squared minus 2ab plus b squared. This was given by a squared minus b squared, where this one was referred to as a difference of two squares. So those are the identities. So in some cases you can factorize using this method of using these identities. An example maybe we can look at, let's look at an example that can maybe have this. Let me say an example. Let's say x squared plus 8x plus 16. We need to recall that a squared plus 2ab plus b squared is actually a plus b squared. So you see we have plus throughout here. That means we can actually express, we can compare these two. Let's compare x squared plus 8x plus 16 with a squared plus 2ab plus b squared. So that here what we are going to check out, we have this, that, that, and we have those three terms adding up together to give these two different expressions. Now let us take a look at the first terms. Since this should be in this form, we can say that that means these two should actually be equivalent. That means we can write something like this: x squared plus 8x plus 16 be equivalent a squared to ab plus b squared. We want to see, because we want to tell you that this one is in this form, so that we compare and see what a is represent, and we see how we can get the factors that by using this identity. So that here, if we compare, we're going to have x squared. We compare that first term, that is going to be equivalent to a squared. If you get root, we just consider this equivalent sign to be like, consider just in mind that like it's an equal sign. So if you take square root on both sides, you realize that your a is actually x. Now let's check our second term, that is 8x and that 2ab. We have 8x being equivalent to 2ab. In that we have here our x given us a already, so that we can say 8a is equivalent to 2ab. So we have 2. If you realize, we have here 2a here and also 2a there. That means we can simply multiply throughout by 2a, so that here would remain with 4 being equivalent to b. So if you realize, we have our b being 4. Now if we compare our third term, that's 16 and that b squared. We have 16 being equivalent to b squared. It actually implies that if you get the root of 16, you have b still remaining 4, which confirms that these ones are the same. So you realize that actually we have, because we want to know this, what takes the place of a and what takes the place of b, so that we just conclude that this expression can be expressed in this form. So here we are going to replace our a with here. Our a is actually x, okay. Then our b was taken by 4, you can see, plus 4. Then you just square. That means that expression is actually this one. It's that means we have the factors is a repetition of x plus 4, that which can be written as x plus 4 into x plus 4. That's how we can see that using that simple one. That's an example. That's how you can use identities. Just you compare them and try to check which one takes the place of, so that you can express them respectively in this format. Here you have an expression given that you have to check for your a and b, get what they represent, and just substitute in that, and you know what you would get. And now we are going to check another method, which is splitting of middle terms. It's a middle term splitting. For middle term splitting, let me say I have x squared. We actually looked at an example about this when we were expanding in our previous video. For middle term splitting, our middle term is this, so that is splitted, but that middle term is splitted whereby that middle term is as a combination of the products of this third term, of factors of the third term, whereby if you multiply those two, you get the product. If you add them, you get this. So we can see that actually that one is got from the product, I mean factors of 6. since in our previous video we looked at how we can come to that, whereby 6 we are supposed to actually get its factor. But now, because this 5, you know that 5 can be split in 5 can be given as 2 plus 3, or the same 5 can be given as 1 plus 4. I think that's all. Those are the possible factors of numbers that we can add to get. But we have to look at one whereby if we multiply, we will get 6, which that would be 2 and 3. And now that means 2 and 3, if we add them, we get 5. But if we multiply them, we will get 6. So that means we are going to have actually here x squared plus our 2 plus 3 into x plus 6. We leave it like that. Then our x squared plus, now we open that, we have 2x plus 3x plus 6. So we had our x squared plus 2x plus 3x plus 6. Now we can just group them. Let me say like that. And we see a common term here is actually x, which is x, which leaves x squared. If you remove x, we are going to remain with x plus 2. If you remove x from 2x, remain with 2. Plus we see common is 3. 3 has 2, 3 times 2, which will remain with 3 coming out, which is common here. Remain with 3. There are 3 into 6 will remain with 2 if you remove 3 from, because now our 6 is 3 times 2. So 3 was common, that's why we pulled it out and remained with that. And now our common factor again here is x plus 2. If we remove x plus 2 in this first term, we remain with x. If we remove x plus 2 from here, we remain with this 3. So those are the factors there. That's what it means to split the middle term, and we actually come out with that. So for actually, we have also seen that for splitting of that, we can maybe check one more example about that. 6x squared minus 13x plus 6. Now our middle term will be given by, we have negative 13. Negative 13 can be given by negative 9, then plus negative 4. That gives us that. But we need to see that, because now this 6, for this time we're going to see that if the one we split here, we must give us 36, because since this coefficient of x squared is not 1, and for us to get the right product here, we're supposed to multiply 6 by 6 to give us 36. So we need to look at the ones, if you multiply, will give us 36. Also we have negative 1. We have actually, I think that's that. For that case, this one is so direct, we have already found it, because if we multiply 9 by 4, we get 36, and we multiply negative 9 by negative 4, we get 36, and if we add them, we still get negative 13. That means our negative 13 can be split into that. In that, we have here 6x squared minus 9 minus 4 into x plus 6. Would have here 6x squared minus 9x if we open minus 4x, then plus 6. I think we can look at here we have 3x in common. We pull out here, we are going to remain with 2x inside. If we remove 3x from here, we have here 2 times 3x squared. So we moved out 3x. 1x will remain to multiply that to remain with that. Then here we have removed 3x, so this is like minus, this is the same as 3 times 3 times x. So we have moved out 3x, remaining the minus 3x inside. Then here we have here a common one is 2. If we pull out 2, we have minus 2 remaining outside, to remain inside with 2x, then minus, we make sure that here once we have removed this minus, we just put it like this to make you get it clearly. we have removed out minus 2, just split, we have minus 4x out of minus 2, then plus 6 out of minus 2. If we split it, you see that this is cancelling, and here remaining positive 2. That's why we have positive 2 inside. But now this will cancel to leave 3, but this negative will affect that to leave us with a minus 3. Here we had no x because here there was only x. So we see that our common factor there will be minus 2x minus 2 minus 3, I mean, remaining in here 3x. If we remove 2x minus 3 in this first term, we're going to remain with 3x. If we remove 2x minus 3 here, we will remain with minus 2. That gives us a factor of that. And that's all for today's video. Thank you for coming to Pure Math School. Please like, subscribe, share, and don't forget to comment. Thank you.